All right, this is 12-6, the locus, which is a set of points. All right, so we're going to write planar space to complete each sentence. So the set of all points in 3 dimensions is space. A plane is represented by a flat surface that extends without end and has no thickness. An isometric drawing shows a corner view of a figure in space. Through any 3 non-collinear points, there is exactly one plane. All right, so new word, locus. Okay, the plural of locus is loci. The related word is location or locate. So the definition, a locus is a set of points, all of which meet in a stated condition. So the locus of points 5 inches from a point of a plane is a circle with a radius of 5 inches. Okay, so is a square the locus of points equidistant from a given point? That's false. A sphere is a locus of points equidistant from a point in space? That's true. A circle with a diameter 3 centimeters is the locus of points 3 centimeters from a given point? That's false. And a locus of points 15 miles from a cell tower is a circle? That's true. All right. So the sketch below shows the locus of points in a plane 1 centimeters from AB. And then how would the sketch change for locus of points in the plane 1 centimeters from line AB? Okay. So as you can tell, by the way, all points, so this is 1 centimeters in all direction. Notice once it hits the end, it needs to turn into a circle, becomes a point. So all of these has to be 1 centimeter. So this is why this figure is the locus of points 1 centimeters from this line segment. All right, so AB extends forever in opposite directions. AB line segment has endpoints. Okay. Would the new sketch have a parallel line segment 1 centimeters above AB? No. Would the new sketch have parallel line segment 1 centimeter below line AB? No. Would the new sketch have a parallel line 1 centimeter above line AB? Yes. Not a segment, but a line, okay. Would the new sketch have a parallel line 1 centimeter below line AB? Yes. Would the new sketch have semicircles at each end? No. Would the new sketch have anything at each end? No. So sketch the new one. All right, so we're going to go 1 centimeter up, perpendicular, 1 centimeter down, perpendicular, and we're going to go this way, and we're going to go this way, and forever in both directions. 1 centimeter, 1 centimeter. All right, so the new sketch would have parallel lines, not line segments. The parallel lines would be 1 centimeter above line AB and 1 centimeter below line AB. The sketch would have no semicircles because the lines extend forever in opposite directions. Okay, so problem number 2. All right, what is a sketch of the locus of points in a plane that satisfy these conditions? So the points equidistant from 2 points, x and y. The points 2 centimeters from the midpoint of xy. Okay. So we're going to use a diagram at the right to complete these exercises. So circle the points in the plane that are equidistant from the endpoints of a segment. That would be perpendicular bisector. Circle the locus of points that are equidistant from x and y. That is the perpendicular bisector of xy. Circle the locus of points that are given distance from a point. That's a circle. Circle the locus of points 2 centimeters from the midpoint of xy. It is a circle with the center at midpoint xy with a radius of 2. So points A and C are the locus of points that satisfy both conditions. All right, what is the locus of points in a plane that are equidistant from 2 parallel lines? So complete each statement with the appropriate word from this list. Points that are equidistant from 2 parallel lines are between the lines. The locus of points in a plane that are equidistant from the 2 parallel lines is a line. Distance between parallel lines is the length of a segment perpendicular to the both lines. So what is the locus of points in a plane that are equidistant from 2 parallel lines? So the locus of points, oh, let me start over here. That's true, but let's get a little bit cleaner up here. The locus is a line parallel to the given lines and halfway between them. Okay. So what is the locus of points in space that are equidistant from 2 parallel planes? All right, cross out the word or phrase that does not describe the distance between the planes. Okay, so this does not, this does. It's the length of segment perpendicular to each plane. Circle the word or phrase that describes the locus of points in space that are equidistant from the 2 parallel planes, and that would be the plane halfway between the 2 parallel planes. All right. So how are the descriptions of the locus of points for each situation alike, and how are they different? In a plane, the points equidistant from points J and K. In a space, the points equidistant from the points J and K. So place a check mark if the description is true for the locus of points equidistant from J and K. Place an X if it is not. So a perpendicular bisector, it's true for a plane, and it's not true for a space. The plane containing a perpendicular bisector, not true for plane, but true for space. Plane perpendicular to the plane containing JK is not true in a plane, but is true in space. So how are they alike? Both contain the perpendicular bisector of JK. How they differ? The locus in a plane is a line. The locus in space is a plane. And that's the end of this section.